In this video, let us see the introduction about analytic function. First, let us start with the definition. Analytic function, or we can call it as a regular function or holomorphic function. So what is the definition is, a function is said to be analytic at a particular point if its derivative exists at that point and also in its neighborhood point. Okay, this is the definition of analytic function. Example for analytic function is e power z, sin z, cos z, or examples for analytic function. So while talking about analytic function, here we are defining the function as f of z, function of z. That is, here if you look at here the example, e power z, sin z, cos z, everything are functions of z. So in general, analytic function we can define as a function of a complex variable. So here let us take the variable z as a complex variable, and so that the function f of z, we can say it is an analytic function and it is denoted as w. That is, here we are using another symbol w, so that we can write w is equal to f of z. So since we are writing w is equal to f of z, and already we know z is a complex variable, z can be written as x plus iy since it is a complex variable. So here in place of z, we have replaced x plus iy, and based on the function f, it may be algebraic function or exponential or trigonometric function, we can apply that function so that we can split it into real and imaginary part. So once based on the function f, we can consider the real part as u of x comma y and the imaginary part as v of x comma y. So that w can be expressed as u plus iv. So that w also contains real part and imaginary part, and u is denoted as a symbol for real part and v is denoted as a symbol for imaginary part. So throughout the section, here we have to consider the notation w as u plus iv, or we can also call f of z as u plus iv, where z is equal to x plus iy. Now based on this notation w is equal to u plus iv, here we have to remember equation called as Cauchy-Riemann equation. So that here we are having two types of Cauchy-Riemann equation. One is for Cartesian form, another is polar form. So if because we can able to express z, the complex variable, in Cartesian form as well as in polar form. So in Cartesian form, z is considered as x plus iy, whereas in polar form z is considered as r into e power I theta. So when z is expressed as a complex variable in Cartesian form, then the Cauchy-Riemann equation is considered like this: dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So this is the equation called as Cauchy-Riemann equation to check whether the function is analytic or not. So this is very important to know about analytic function. Next, this is for polar form. So since polar form means it is a function in terms of r and theta, so we have the Cauchy-Riemann equation in terms of r and theta. That is, dou u by dou r is equal to 1 by r into dou v by dou theta, and dou v by dou r is equal to minus 1 by r into dou u by dou theta. So that here dou u by dou x, dou v by dou y, dou u by dou y, and dou v by dou x are partial derivatives, first order partial derivatives. Likewise, here in polar form also, both u and v are differentiated with respect to r and theta, and these also represents the first order partial derivative. So here talking about analytic function, here we want to know necessary condition and sufficient condition for the function to be analytic. So first one gives the necessary condition for the function to be analytic. So here we already saw what is Cauchy-Riemann equation. So the Cauchy-Riemann equation is called the necessary condition for the function to be analytic, which means that a function should be an analytic function, means definitely it should satisfy Cauchy-Riemann equation. So that here we are having under necessary condition, we are having Cauchy-Riemann equation. So here we have used the symbol ux, vy, uy and vx it is also another symbol which is denoted for first order partial derivative. So either we can use this equation using the notation, or otherwise we can also use this notation. Okay, both are same. Next is sufficient condition for the function to be analytic. So here we are having two conditions. First one is these first order partial derivatives are continuous. It should be continuous. And second thing is, again it has to satisfy Cauchy-Riemann equation. Okay, so this is called as sufficient condition for the function to be analytic. Now let us move on to the problem. Here, test the analyticity of the following function. That is, here a function is given, f of z is equal to z square. Similarly, f of z is equal to z bar. So we have to check whether this function is analytic or not. So suppose if you want to check a function is analytic or not, here we have to check for this condition. So what is the necessary condition here? It has to satisfy Cauchy-Riemann equation. So we have to check whether this function satisfies this Cauchy-Riemann equation or not. If it satisfies, we can conclude that the function is analytic. If it doesn't satisfy, means we can conclude that the function is not analytic. So now let us start with the first question, that is f of z is equal to z square. So here z square means z can be written as x plus iy. So since it is z square, we can write it as x plus iy the whole square. Since it is x plus iy the whole square, we can able to split it as using a plus b whole square formula, so that it becomes x square. Iy the whole square will give you minus y square, because I square is minus 1, plus 2 times of I into xy. So here if we notice, here x square minus y square, there is no I term, but here 2xy we are having I, so that we can say that this is real part and this is imaginary part. So that always we told you that W is expressed as U plus IB. So U is being the real part and V is the imaginary part. So here what we have to do here is we have to consider U as x square minus y square and V as 2 into xy. While writing here, we should not take I. Apart from I, remaining thing is considered as imaginary part. So why we are taking u and v? If you know what is u and v, then only we can able to check the Cauchy-Riemann equation. So to check this Cauchy-Riemann equation, first we have to identify u and v. So that here we have we have identified u and v, where u and v are functions of x and y. So now we have to find out the first order partial derivatives. So what is the first order partial derivatives? So here we have to find out dou u by dou x. What is dou u by dou x? Partial differentiating u with respect to x will give you 2x. Similarly, dou u by dou y. So what is dou u by dou y? It is minus 2y. Next, what is dou v by dou x? Dou v by dou x is differentiating v with respect to x gives you 2y. And then dou v by dou y is 2x. Now we have to check for Cauchy-Riemann equation. So this is the Cauchy-Riemann equation, that is dou u by dou x and dou v by dou y should be same. So if you notice here, dou u by dou x, that is this one, and then dou v by dou y, both are 2x 2x, so both are same. So we can have the first condition, dou u by dou x is equal to dou v by dou y. And what is another one? Dou u by dou y is equal to minus dou v by dou x. So what is dou u by dou y? Dou u by dou y is this one, 2y. And what is dou v by dou x? Dou v by dou x is this one. This is actually dou v by dou x, and then dou u by dou y is this one. So both are same term, but which differs in negative sign. Okay, so the same thing only here we are having in Cauchy-Riemann equation. So that here we can say that dou u by dou y is equal to minus dou v by dou x. So both the equations in Cauchy-Riemann equations are satisfied. So that, and moreover, all the first order partial derivatives are continuous here, because all the partial derivatives, first order partial derivatives are algebraic function, and hence it is continuous. Okay, so that here it satisfies Cauchy-Riemann equation and all the first order partial derivatives are continuous, so that we can conclude that the function f of z is equal to z square is analytic. Now let us see the second question, that is f of z is equal to z bar. What is z bar? Z bar is nothing but x minus iy, that is complex conjugate x minus iy. So it is easy to write what is u and v. So u is equal to x and v is equal to minus y. So that we can find the partial derivative dou u by dou x as well as dou u by dou y. So what is dou u by dou x? It is 1. Dou u by dou y is nothing but 0, because there is no function in terms of y. And then again dou v by dou x is 0. It is independent of x term. And then dou v by dou y is minus 1. Right? So now we shall check for Cauchy-Riemann equation. So Cauchy-Riemann equation is what? Dou u by dou x should be equal to dou v by dou y. So if you notice here, dou u by dou x is 1 and dou v by dou y is minus 1. So that here what happened, dou u by dou x is not equal to dou v by dou y. So hence the CR equation are not satisfied. So that we can conclude that f of z is equal to z bar is not an analytic function. Okay, so this is an example for the function is not an analytic function.